Sorry for the delay there, guys. I hopefully will be roughly 20 minutes regarding this talk. But first case first, introduce myself. My name is Ian Taylor. I'm part of the business development conservation team at Naturemetrics. Today's talk hopefully just gives you guys a little bit more of an insight in terms of who we are, what we're doing, why we're doing it, and also a chance to see how maybe some of your short and long-term sort of projects can be integrated into eDNA monitoring. But before I get into eDNA and what it stands for and the uses and its applications, I thought it was always quite a good way to start at the very beginning. I think it was in 2009, after I became a fully fledged marine biologist and a dive master. I think I rooked up about 550 dives. I realized I was seasick, and obviously I knew that going in, but I thought that it would just go away, but it didn't. So after coming to terms with that, I had just wasted 5 years of my life. I became a terrestrial conservationist instead, so became a field guide in Africa, and I think it was after about 15 months in and out of the bush. It's a really intensive course. It's like a degree in 3 months. I was stood at one of the Drakensberg Mountains with my instructor, and we're looking out as far as the eye could see. And he turns to me, and I'll never forget what he says. He says, "Ian, there's so many people that love nature." I'm like, yeah, of course. He says, "But it's all for nothing unless we can figure out a way of monitoring its biodiversity." And that point stuck with me ever since. And I thought it's quite prudent to then bring up the next slide at the fact that 13 years on, I think it was April this year, Inga Anderson, the head of the UNEP, stated that biodiversity is ranked as a top global risk in regards to likelihood and impact. And I think it's organisations like us, like everybody here, and individuals that here that are willing to do something about it. Because I think when you're setting a company up, there's always that need to identify the challenge. What can you do? Can you do it? And what the applications and is the solution solved? But biodiversity is complex, as we know, farming systems, river catchments, estates, forestry enterprises, conventional surveys, and that do a wonderful job and that assess and monitor biodiversity can be time consuming. They can run up big expenses. And tying that in with the understanding about the complexity is that with nature being complex, it doesn't have to be overcomplicated. Nature does unfortunately have a bit of a measurement problem, and I think we've probably all understood over the past 5 or 10 years how many insects are you wiping off of your windscreens these days. It's not very many, is it? And there's huge companies out there that are doing some great work with newts, bats, badgers, which is wonderful, but it's a little bit like Google Maps predicting traffic flow based on just a handful of cars, and it doesn't really work, which is why we need to augment, and we need big data to push this through. And with eDNA, you're able to extrapolate, you're able to go deep, and you're able to understand a full variety of species that are within a very, very small volume. So roughly ranges to about a litre of water that we push through these filters. And that can be sort of transferred or transcribed in terms of 5 to 10 years worth of conventional data based on the fact that that 1 litre can provide more taxa. So looking at the taxa only. But moving forward here, I think it's really important to note that we all started from trying to solve a problem, and Kat Bruce, our founder, who came up with this whole concept, I think it was in 2015. She was actually doing her PhD in the Amazon, morphologically IDing a lot of different insects. I think it was ants to be specific, but her professor, I believe, gave the application of try this eDNA thing, it might help. Anyway, 5 romantic years and a great story later, I'm going to condense down into 10 seconds. She was able to bridge the gap between the molecular scientists and environmental practitioners by putting it into the hands of game changers, the field guides, the environmental scientists, the protected area managers, the conservationists, and we were able to put that gap together in order to understanding the bigger picture, which I think helps understand the scale. Now, in terms of who we are, every time I give this slide, it's out of date. I mean, we're up to about 80 staff members now, 300 clients and 20,000 samples, but we've been doing this since 2016, and ultimately we started and became very proficient with newts. So that's ultimately where we began and sort of started to make our name. But as you can see, working with the likes of the Wildlife Conservation Society, from WWF, Natural England, wildlife trusts, NGOs to farmers, people in their back gardens, and then big companies that are looking to try and make a scale-up version. This is everywhere across the world. So I think we're working in 4 continents now. So certainly we've branched out, and as we've branched out, there's been a number of people come to to Nature Metrics. I think we're, as I said, 80 now. So we've got these nice, wonderful offices, which is great to state that we have the largest, most sophisticated eDNA lab on planet Earth, which is always a nice, lovely statement. But in regards to growing, there's also growth in terms of expertise. So we understand that there's a need for this data across sectors. So when you're working with the private sector, we work closely in trying to understand the gaps and try and get a better idea of baselines. With consultancies, it's more of an approach of augmenting data for endangered species and monitoring impact for validation studies. And in regards to biodiversity consultancies, we have an industry briefing note, so showing the strengths of using eDNA. So eDNA, what does it stand for? I was on a call last week and they said it stands for exciting DNA. Well, I suppose it is, but it actually stands for environmental DNA. So environmental DNA here, this is everything that animals sort of shed. So this can be anything from feces, skin, hair, fur, anything that they shed can be picked up in these water samples. Now, it's important to note residency times. So residency times for water is slightly different to that of soil. So residency time for water is more hours to days, whereas soil it's more weeks to months. So this is good news actually. So when you're running a filter kit, when you're running one of these analysis in the river or any body of water, we're never capturing historical traces. So nothing past 5 or 6 days really. So we're constantly capturing present and current data, and this can give a really sort of high temporal resolution of what is out there. However, there are considerations, and there's always a comparison to the likes of, say, electrofishing and so forth. But with regards to electrofishing, that does things that eDNA doesn't do. It's sort of a different conversation, really. It doesn't perform health checks on fish, for example. But other considerations would be certain species like amphibians, reptiles who have a low metabolic rate, so therefore little shedding, so they can be slightly harder to detect. Considering breeding, considering behaviour, seasonality, it's important to note that, say, water voles, for example, they're a good example of this. Official survey guidance is between sort of April and October. Ideal times more sort of June to August. That we need to consider that into the approach. So there's so many questions in terms of wanting to understand how to measure biodiversity, which is why we do seem to ask quite a lot of questions to begin with, but ultimately that's the long-term benefits and creating validity to the project. Beavers, very easy to detect, whereas otters, mink, they're quite notoriously difficult actually. They latrine outside of the water. And I think a recent study that came out earlier this year suggested that because of their high dense fur ratio, they actually don't shed fur as often as other mammals, again, making it slightly difficult. So all these factors come into play when we're looking to detect certain species. But the kit itself, it's been democratized. My 10-year-old has been able to do this. So everybody can participate in running these surveys. So in regards to citizen science projects, again, it ticks that box, which I think is lovely. And you can collect these samples within about 20 minutes. No cold storage is required, there's no batteries, no pumps, no heavy equipment, which is certainly useful when you've walked 2 or 3 miles to a site and realised, oh, I've forgotten the battery, and you have to walk all the way back. So it's very simple, very clean, and we're able to run, which is where the scale up comes in, up to 4 different groups and only 1 assessment. So that can include vertebrates, fish, mammals, amphibians, for example, inverts. So we can run 4 different groups at one time, normally running about 100 samples at a run, which spits out 100,000 sequences. So that's a heap of data. But ultimately, what are we doing with that? So you see the kit on the far left there. So the filter, we push the water through this filter and then put the preservative solution through it. We cap it off. We use the infield app, and then we send that information back to us, and everything's live and geolocated. So super easy. Everything is then portrayed back to us, and we then formulate this in the form of presentation report, which can be NMDS plots to species by sample tables, heat trees, for, just for a quick example. Here, what we can actually do is we're focused a little bit more on water kits, but we also do a lot of work with soils, especially looking at soil metrics, soil health, biodiversity, and ultimately trying to understand where we can capture eDNA and ultimately species presence. So 2 questions really. Is species X present? So there's on the far left, that's single species, and that's transferred into something called a qPCR. So you're looking for one particular species. The other one, which is multi-species, which is metabarcoding or MBC, these are species that are present from a taxonomic group. So that's a very nice way of getting lots of biodiversity data. Important thing to note is that the less charismatic the species, the less chance of it being in the reference database, but this is something that's growing all the time. In terms of the application, here we can look into water, so our aquatic kits, tissue, so barcoding kits, feces, which is known as our species from feces kit, bulk inverts and vertebrate kits, and then soil and sediments, which focus predominantly on fungi, metazoa, and bacteria, and that would be our soil kit. The important thing here to note is not only is it the data democratized, as I mentioned, is that we can store all of this eDNA for up to a year. So there's no need to revisit a site. And that comes into play in regards to that certain projects might have limitations, i.e. budget, or you might have changed your mind simply and wanted to run the analysis on the mammals that are the sample you gave us. There's no need for you to revisit those sites. We can do those sample analysis up to a year after you've given it to us. So again, looking at ways to sort of reduce the costs in terms of augmenting the data. Oh, should have shot through there, sorry, quite quickly. This is just a nice simple way for you to understand the correlation of how we focus on some of the categories in terms of species. But ultimately, we take your DNA sample, we extract the DNA, we sequence it on a high throughput sequencing platform. We then match that sequence against the reference libraries to ultimately assign your taxonomy. And from each sample, you can generate data on many different taxonomic groups. So you can generate really comprehensive biodiversity data from an extremely efficient field sampling program. So very simply, you can scale up to big data quite quickly. Now, in terms of the sort of end-to-end service that's applied here, I mentioned briefly about the bioinformatics and the reporting, but it's everything that starts. So we know that if you're talking about one individual or a small committee that's looking to run work on a local river, stream, pond, this is important to those people as is a big company coming in that's important to them. So it's all individually treated. And I think the bespoke value of how we move this eDNA kits through the region to nationwide and how we've done it internationally is ensuring that everybody is up to speed in terms of what we can do and what the applications can and can't achieve to make it realistic. This starts with the debriefing of ultimately what you're after, but this then derives and moves forward to allowing everybody to holistically understand what it is that you can and can't achieve. Now, if you're going back to the single species, so if you're looking to determine one particular species in an area, that can take anywhere between 5 to 10 days. If we're looking at the metabarcoding, so the multi-species, looking at variants and multiple species within taxonomic groups, that can take up to 8 weeks. So there's a difference in the time scales there. Some examples, which I think is always quite nice to understand, and who we've been working with, and what the results have been. So this is with the WWF, which was a pretty cool example to sort of highlight to you. And they were particularly keen on running a baseline survey, but on qPCR. And what they wanted to run is analysis for the pink river dolphin and the Amazonian manatee. Ultimately, we had big chats, and this is where those questions come in, that we kept firing those questions off at the start. And we figured out that actually, if we don't run qPCR and we run some metabarcoding instead, we might be able to detect a few more species. So we did. And ultimately, this gave some phenomenal results, but it initially allowed us to understand the abundance and presence of where the dolphins were particularly focused. And this was really helpful to look at species across the landscape. And for the manatees, we were able to understand that their population was quite localized. And what the WWF did with this information is they put speedboat restriction bans. It sounds odd, speedboats in the Amazon, but they're there. Speedboat restriction plans in certain areas to reduce collisions, reduce injuries. And that was just one of the first things that they started to do. But going back to looking at just 2 species, or looking at 675. So by running an MBC on the same river with the same kit, just adding to different analysis, we're able to look at 675 different species. That's huge, whereas you're just potentially looking at 2. All this was gained within 8 weeks. So from that, you can understand that you get the charismatic and the mammal-centric data from the leopards to the tapirs, but also the slightly more elusive species as well. Appreciate 375 were fish, but you can see 155 of those were mammals. And this had some lovely complementary data as well in terms of the reptiles and amphibians. As I do hopefully remember from before, I mentioned that because reptiles and amphibians have lower metabolic rates, it does make them a little bit more difficult to detect, but still we were able to detect them. Here, and ultimately one of the things that they started to look at was the machine learning practice that we have. So looking at landscapes and the differences of species communities from one another. So we're able to ID a different set of fish and found at their site. So there was a waterfall, so acting as a barrier. And this is creating a divide, if you like. But this information helps management decide on how and where to protect some of those more isolated groups, especially from things like pollution. That then opens up questions in terms of how interesting the application can be. So that's all from just two analysis that was taken on in the WWF, which from 2 species to 675 is quite a nice sort of sample set to look at. The sort of final sort of case study here, one that's been a little bit more closer to my heart in terms of soil studies moving forward, was the Woodland Soil Project. And this is one of our recent soil works. This was a baseline survey, so that after the trees are planted, we can then do ongoing monitoring to see how diversity and composition of the soil communities change in the planted area. So that's one of the things we're looking at with soil at the moment, and some driving force in terms of questions is, what can we measure over a period of time, and how are we measuring that? So this was based on 2 habitat types, the plantation woodland, which was conifer as well, and unwooded pasture. Here, so these are the heat trees. This is really, really good in terms of site comparisons, but we can also display the data in NMDS plots, which are non-metric multi-dimensional scaling. So clustering of samples to show difference. So snapshot in time here, but going back to show changes over time. So there's an aspiration to assess if the plantation woodland is having an impact upon it being changed, or if the unwooded is being changed to see a trajectory towards the natural habitat. But that's very much just working with species data that we're able to anticipate. And here from the soil fungi and soil fauna, we're able to look at community bases and able to extrapolate that and show comparisons. The way that our BI team now is heading is, our business intelligence team is to be able to monitor progress and restoring ecosystems to achieve biodiversity targets. So looking at developing health metrics to show progress. Now, ultimately, we're wanting to show and monitor and provide and produce going from degraded to healthy. So this is where we're moving towards in terms of measuring changes in soil biomass and composition metrics. Ultimately looking at soil restoration, and these are a number of the baselines that we're participating in at the moment. Being able to, across the landscape, rank various compartments of biodiversity importance to allow for conservation planning to take place, and similarly identify where restoration would be best prioritised. That's one of the key things that we're able to provide a lot of our customers with now, the prioritisation of where we should be focused. But rewilding comes into play here. Now, rewilding is very romantic, very beautiful. My heart starts to jump a bit when someone mentions a rewilding project, but rewilding programs aren't necessarily like other projects. They don't necessarily have much of an end point. There's a beautiful quote that I heard not so long ago. There's an ounce of hope is worth a ton of despair. And I think that is something that we live for within the biodiversity world when you're looking to try and conserve it. And when you're able to scale up, it certainly, we're able to answer those questions at a quicker rate, at a rate that we're needing to, and sit alongside traditional surveying techniques and complement that data. So the final slide now. I mean, to sum up, this is a decade of restoration, and eDNA metabarcoding is accurate and repeatable, and can reduce health and safety risks, and reduce costs and timeframes. But ultimately, we're developing reference libraries which are helping this massive scale-up approach to allow for people to understand the bigger picture of what is out there rather than just specific species. In regards to working together with our scientists, this is ultimately to support our clients to use DNA-based solutions to ultimately answer questions about environment and biodiversity. We basically figured out how to turn nature into data, and captivating and biodiversity at a previously unthinkable scale. We're able to capture that and move forward productively, and hopefully in a manner that people can access this data, and we're all moving in a way that we can note biodiversity loss, and then we can hopefully ascertain how we can prioritize and look to produce biodiversity gain. Much for your time, and hopefully you've got some questions for me that's formulated, and hopefully I can answer some of them.
Cool. Thank you very much, Ian. Oh, that was really interesting. And I've got a little bit of an echo. Hopefully we'll stop. Yeah, there are. Can you hear me? Sorry. There's a few questions that have come in. The first one being in reference to the otter and mink presence. If you tested after, it's just flipped up. If you tested after high water, you should get washed off scent smears and sprint. So would that be good practice for detecting them?
Yes, it would. Yes, so when we go into those into that detail, that is one of the points in terms of high water, in terms of fresh water, sorry, in terms of rainfall as well, in terms of runoff. So that does allow for slightly better detection, and however that does sometimes interfere with fish species detection. So if you're looking at a particular species, then yes, that is certainly a parameter that we would focus on with you and sort of highlight in terms of the caveats of running some of these assessments. But yeah, really good point, whoever made that point.
And how young would the spraint or scat material need to be in order to be detected?
Oh, we're talking more sort of days to week, really.
Right.
Rather than months and months and months. Yeah.
Cool. Thank you. And then same person's got another question, which is, with large catchment rivers like the Amazon, for example, how do you know the DNA is localized and not washed miles from different tributaries, e.g. the manatee localities? The DNA is not washed from an area, and the test area is where the water might accumulate the sediment DNA.
Yeah, again, that's a formidable question. We run control sites, and we run multivariants in terms of the replicants, where we're taking subsamples. So each one of those samples are made up of anything up to 40 subsamples to try and give us a better location in terms of that. Again, that's one of the things that we would look at and consider. It's a very good question, but we try to overcome that with subsample plotting and replicants in regards to the sampling, to give us a more of a in-depth look at presence. One of the things that I didn't mention actually, which I should do, is that it's not necessarily this data is used to provide relative abundance. It's more of a proxy for abundance, I should say, with good scale data sets. So I think that, yeah, that's one of the things that I didn't mention in the talk, but yeah, it's a very good question.
Cool. Thank you. There's a couple more that just come in. Hopefully these are shorter ones. Andy said, do you use different genetic markers for different taxa?
Yes. Yeah, that's
very short one.
I could go into that one. Yes, we do. I'd love to sort of envelope and push that conversation forward, but or treat it on a case-by-case basis. But yes, we do.
Okay, cool. Thank you. And then the final one from Jane, who says, financially, could this be part of on-farm programs for soil?
Oh, yes. So we're currently doing quite a work with a lot of estates at the moment and some farms in the north to the south, the east and the middle of the country, which is about as vague as answers I can provide. I'm not a politician, I promise. But yes, we most certainly can. We also have some academic rates that are also quite favourable to certain people, and also NGO rates where we can try and work in some better pricing to allow for people to understand exactly what it is that they're trying to assess. Sorry. Excuse me. Thank you.
That's brilliant. Thank you very much. I'm just conscious that we're trying to stick to time.
Sorry,
so there's one more question, but it's about cost. That might be more of a direct question to you that I can always forward on any questions that we don't have time, and then maybe
feel free to email me.
Yeah, but that was brilliant. That's really interesting. Thank you very much.
No worries. Thank you for your time. Thank you, everybody.
Thank you.